How's it going, everyone? We have this topology here where we have a campus network that we have to set up, where on the left side we have an office that has an admin, user, and a printer, and on the right side we see a data center where we have a DHCP server. Our task here is to build out this network to where our devices on the left side can receive DHCP addresses from the server on the right side. And if you see on the left side of our topology, we have 4 boxes that explain the tasks that we have to do from day 0 to day 3. In today's task, we're going to do configure the office router, the campus router, the data center router, and we're going to configure EIGRP across all 3 devices, and ensure we have connectivity and neighborships between each device, and then test connectivity between the routers to where we can ping from the data center to the office router. So let's go and jump into our campus router real quick. We're going to go to global config. I'm going to send a no IP domain lookup and a no logging console. These 2 commands are not really necessary in this configuration, but it's going to save you some annoyances later on if you put in a bad command. It's going to try to telnet to an unknown domain, or logging consoles are going to pop up in the middle of you typing. It's just kind of good practice, get these out of the way so you don't have to worry about that. So we're going to give this guy a host name of campus_router. And then let's look at the interfaces that we have to configure here. So on the office side, we have gig 000, and on the data center side, we have gig 002. Let's jump into gig 002 to start with. We're going to assign an IP of 172.16.0.5 with a /30 mask. Now, routers out of the box, all ports are disabled by default. So we have to send the no shut command to enable it. So let's go ahead and do that. And we should see link lights pop up going to the data center core switch as soon as we send this. And there we have it. Now let's jump into the gig 00 interface. So if we look at the middle of our topology at our campus router, let's pay attention to the fact that it's an ISR 4331. If you haven't had any experiences with this model type of router, the 4000 series, on this specific model, you're going to see that you have what looks like 4 different interfaces, but actually 3 interfaces. And specifically, if we look at gig 001, you'll notice that's an RJ45 port that's recessed into the router. You can't change that, it's built in, it's how they manufactured it. And if you look at gig 002, we see an SFP port here, where you have a single mode SFP. In the real world, it could be single mode, multi-mode, or even RJ45 SFP. In this instance, with Packet Tracer, it's going to be a single mode SFP. You can't change the fact that it's an SFP port, that's just how they designed it. If you look at gig 000, you have the option between an RJ45 port or an SFP port. So in this instance, you have to define what media type you want to use, or else by default, it's going to try to use the RJ45 port. And if you know anything about like the configurations within Packet Tracer, we know that this red line here is defining a fiber link. So we have to use an SFP media type. So to kind of show you what I'm talking about, we're going to jump into gig 000, as I mentioned, and we're going to assign an IP address of 172.16.0.1 with a /30 mask. And at this point, if I were to send the no shut command, you would expect that the link would come up, but we'll see why it doesn't. And the reason being is because, as I mentioned before, by default, it wants to use the media type RJ45. And we're using a fiber link. So we have to define it as an SFP media type. And we're going to send the command media type SFP. And once we do this, then the link should come up. And there we have it. So we are going to save our config, and we're going to come back to the campus router later. But let's go ahead and jump on over to our data center core switch. And go ahead and get that guy configured up. Run on over to global config, do the no IP domain lookup, no logging console, and give it a host name of DC_core. And we have this link. Our uplink is going to be, if it will come up, gig 111. So let's jump into that interface. And switches out of the box by default, all ports are enabled, all ports are switch ports, and all ports are access ports. So if we want this port to function in any other way other than an access port, we have to tell what mode of operation we want it to be in. In this particular instance, we want it to be a routed port, so we have to disable the switch port functionality of it. And the way that we're going to do that is we're going to send the no switch port command. Now that we've done that, we can go ahead and assign an IP address to it. So 172.16.0.6 with the /30 mask. All right. So now that we have both sides of the campus router facing the data center core and the core switch interface, let's see if we can ping the campus router from the data center core. So we're going to do ping 172.16.0.5, and we should get some replies, and we do. So now that we have our interface configured on the data center core, let's jump on over to the office core router, or office core switch. All right, same deal. We're going to jump into global config. We're going to send the no IP domain lookup and no logging console. Give it a host name of office. Spell that right. Office _core. And also this should also be gig 111 for the uplink as well. So we're going to jump into interface gig 111. And once again, we have to send the no switch port command to make this a routed port. Assign an IP address of 172.16.0.2 with a /30 mask. And let's go ahead and test that we can ping the campus router 172.16.0.1. And we can. Now, I'm going to show you why, or the fact that the campus or the office router cannot ping the data center router. So let's see that if we can ping it or not. We know that we can't, but I'm going to show you that we can't. And the reason behind this is that routers, the purpose of a router is to separate broadcast domains. And with that being said, you have to have a routing protocol to tell where packets should go in a separate broadcast domain. So the next step that we're going to do is we're going to start configuring EIGRP. And we're going to start in the campus router. So once again, we're going to go to global config. Now we're going to jump into router configuration mode with EIGRP. Unfortunately, in Packet Tracer at this point, they don't support named mode, so we only have to work with, or we only have the availability to work with classic mode. So we are going to do EIGRP 10 for our autonomous system number, and we're going to define the networks that we want to advertise into EIGRP, which in this case will be 172.16.0.0/30. So network 172.16.0.0 with a .3 wildcard mask. And then we're also going to do network 172.16.0.4 with a .3 wildcard mask. And now, with a little bit of security in mind, because we can't, also Packet Tracer does not support authentication for EIGRP yet. So one thing that we're going to do as a practice is we're going to explicitly define what links we want to operate into EIGRP or advertise into EIGRP. So we're going to make all interfaces passive by default, which means that they're not going to participate in the EIGRP. So we're going to send that passive interface default command. And we're going to explicitly state what interfaces we want to actually be non-passive so we can participate in EIGRP. So we're going to send no passive interface gig 0/0/2, which is facing towards the data center. Do command recall, and we're going to do 0/0/0 going towards the office core. So now both links are participating in EIGRP on the campus router. So now let's hop on over to our data center core. We're going to go to global config. Once again, go router EIGRP 10. Oh. So this is a good point to kind of point out that all switches out of the box are layer 2. So you have to tell it when to enable routing features by sending the IP routing command. And now it is capable of actually using layer 3 routing protocols such as EIGRP, OSPF, BGP, and like. So now we're going to jump into router EIGRP 10 router configuration mode. We're going to find what network we want to participate into EIGRP. So 172.16.0.4 .3 wildcard mask. So at this point we should have a neighborship. So we're going to check by doing do show IP EIGRP. And there's two commands I like to use. There's more than just two, but these two commands I particularly like to use. That's show IP EIGRP interfaces and show IP EIGRP neighbors. So let's send the interfaces command. We have a peer. It'll tell us what interface it's peered on. And so the next one that we're going to use is the neighbors command. So neighbors. And that'll tell us the IP of our neighbor, what interface, and how long that neighborship has been up. Now, just as on the campus router that we made every single interface passive by default and explicitly stated which interfaces we want to be non-passive, we're going to do the same thing on both of our core switches. So we're going to do passive interface default. And I'll point out to you by using command recall that once we do that, effectively the EIGRP neighborship will have died. So we're going to do show IP EIGRP interfaces, and you'll see that there's no peer now. Same thing with neighbors. The neighborship is down, but as soon as we state that we want gig 111 to be non-passive, it will restore that neighborship. So interfaces, we have a peer now, and neighbors, we have a neighborship of 5 seconds on the same interface with the same IP. So let's do a test ping to the router, make sure we can still ping our router. So .5, we got 5 good replies. All right, let's save that command or that config real quick, and let's hop on over to the office core. Just do the same thing that we did on the data center core to the office core. So global config, enable routing, and then router configuration mode for EIGRP 10. Advertise our network, so 172.16.0.0 with a .3 wildcard mask. We're going to make all interfaces passive by default. Explicitly state what interface we want to be non-passive, which is gig 1111, and verify that we have a neighborship. Interfaces, we have a peer, and we have our, gosh, I gotta work on my spelling, don't I? And my neighborship. So something to note is that if you have a peer, you have a neighborship, and you have a neighborship, you have a peer. They're the same thing. It's just two ways to find the answer essentially. So at this point, all 3 of our layer 3 devices, the office core, the campus router, the data center core, are all participating in EIGRP in the same autonomous system. So not a whole lot deeper that we have to go into this, other than the fact that let's now test that we can ping from the office core to the data center core. So we're in the office core switch right now. Let's go and see if we can ping on over to the data center core by pinging 172.16.0.6, and we can ping it. And just for the sake of it, let's go ahead and go into the data center core and vice versa, ping on over to the office core switch, and we can ping that as well. So that is going to be what consists of our day 0 tasks. We'll jump on into the day 1 task in the next video. So join me there, and thank you for watching.